the objective of this demonstration is to develop the data of sine of x curve, right, in a Fortran program. So for generating these pairs of values, the pair of values, so I would start from 0 and I will calculate a value of sine of 0. Then in the next step, I will add, say, zero point 0.1. So then I will calculate the value of sine of x. Then I will add the difference delta x, which is zero point 0.1. So a new value for x is generated, and I will calculate a new value for sine of x. And up to so on, I will get up to the mark, which is 3.14, okay, a value which is equivalent to pi, right? Or some more value to that one. And in these steps, like getting a new value of x and calculation of sine of x, this will generate the data for sine of x. So I will initialize the value x from 0. Then I have to assign the delta. So I can define a variable delta and set this value, okay, 0.1. I can calculate sine of x. It is available in the intrinsic library of Fortran and also in all of the libraries. So then there is going to be a calculation, say y equal to sine of x. Then I will print this out. I will print that one, right? And then I have to generate a new value. So new value will be x plus delta, right? And then I have to calculate a new value, which is sine of the new value, right? So algorithm is very simple, right? I'm generating a new value of x, calculating the sine of x, and then print the two, right? Print x value and print sine of x value. So this can be directly called or it can be calculated, right? So I have to repeat these steps, right? These are the steps that needs to be uh, be repeated, right? So let's write the program version for it. So I prefer Notepad++. Okay. Not now. I hope everything is visible to you. So Fortran standard 77 requires a writing program in the 7th column, starting from the 7th column. So program, I call it the plot data, right? So I hope with the uh, preservation of my voice, my messages will remain in the recording, right? And otherwise, we write these things in the comments. So plot D, and quickly I would like to save this program in the working directory, which is in G77 compilers folder, bin folder, and I call it plotd.for, and I will save it not as a normal text. I will save it as Fortran free form source file, since we are using Fortran 77 plus. So, okay, we have the record of previous four programs. Okay, so it has been saved in the right directory. Let us try to have this one beside my algorithm. Okay. Okay, this is fine. So I start with the implicit none, which means declaration of variable must be explicit. I will deal with the input variables x. Okay, I will deal with the constant pi. Uh, Maybe we may not require the pi variable. Uh, okay, then real, is it required? Okay, let's deal with the lesser number. Okay, so I print here the value of x and a value of sine of x, right? So this is very fine, and I can say print x. So this is for the value of x, and the next would be sine of x. So I hope you all know that these are going to be printed as such as text thing. Okay, then, well, I require the delta value. I require the delta value to be initialized as the difference, and x needs to be initialized. Yes. So initialize x equals 0 and delta equals 0.1. So now I write, okay, let's write it. Do while x is, when x is less than 3 point, okay, 3.6, right? Do while x is less than 3.6, right? X equal x plus delta, and print x and sine of x. So this is the updated kind of thing. And then there is going to be an do. So I hope this will generate a kind of a table. So, okay. So here I write a comment, steps to be repeated, right? Steps to be repeated. Let's save this program and run it. I have to get to the directory, scientific computing. Here is the compiler and the bin folder, and we have to access this folder from the system, which is cmd. Okay. cmd. Okay, so with the black screen, we are in the right folder. So I confirm that my file has rightfully been saved over here. So it is plot d.f. So my intention was to save it with .for. So, okay, so CLS, if you, well, G77 is going to compile that one, but I write here a command, plot d.f, to be renamed as plot d.for, right? So with this one, if now I see, then the file has been renamed as plot d.for, right? So renaming is that straightforward from here. So CLS, right? And now let's compile the file G77 plot d.for minus O, make an object file with the name plot d.exe. Oh, the heartbreaking, breath breaking kind of moment. Nothing has been returned. So it means something has been created. So if we see the latest files, um, date modified, date modified. Okay, so there is plot d dot for, and there is the new file which has just been created at 9:22 a.m., which is the consistent time with my computer's clock. So this is the application file. Previous was the .for file, Fortran file. There is one Fortran file with the .f extension. So both are allowed. Okay, now let's see the output of our program. So plot d.exe. Lo and behold. So we have got many values. So it has got to 3.699, right? So actually, when the check was performed, so the value was then updated, right? So less than 3.6. So this file does not exist. Okay, no, I should open the latest file with the name changed, date modified. So plot d.for file. Okay, so see here and analyze the output. Okay, with the previous values, we can check, right? So the data has been generated with the default precision for real numbers. And then with the negative sign, there is some disturbance. We would like to handle that one. So it was 3.6 was around here, right? And then a new value was generated because the value was still less than 3.6. So it computed a new value, x equal to x plus delta x, and then it computed the sign of x. So it is consistent with whatsoever we wrote, right? So now to eliminate this kind of you can say a slightly unpleasant feature, I'm going to add something over here, the new thing in this asterisk, right? So I'm going to write here, right here. Okay, well, this should be over here. Okay, I write here 1x, then I write here f 10.4, and then 2 times x, and then I write f 10.4, and that's it, right? So I have changed the asterisk. Now I am rightfully inside the asterisk. So it is to override the default option. So I save the program, and I would now like to see whether these commands have been accepted by the compiler or not. So I write cls, I delete the previous file plot d.exe, right? So this is there. Then now I recompile G77 plot d.for minus o plot d.exe. So program has been successfully compiled, right? And we are ready to see the outcome plot d.exe. Plot d.exe. Okay. Well, this is the same one. I deleted plot d.exe. Well, this is not the output of the program. I asked that one. Okay, so this was saved from here. I have the right indication. CLS. Again, I delete plot d.exe. Now I have to confirm that one from the bin directory. Plot d.for, right? It has been saved at 9:26. Okay. print command. Oh, it has been adopted. It has been written outside the loop, right? So I require that one inside the loop. So don't blame computer, right? Just be patient and look for the error, interpret it correctly. Well, you see, when in Notepad++, it is red over here, it means it has not been saved. So the saving is now confirmed. Okay, so now with the up arrow key, I can look for the older commands. So compiled and executed. So see the 4 decimal places. 4 decimal places, it means it has been controlled from this 4, right? And the 10, they refer to the spacing. They refer to the spacings. F refer to the floating point. So if you are going to write a real number, you have to use the F identifier. You have to have the number of columns to be specified for writing that number. So you will find similar demonstration over the internet from my videos. So let's stop at this point. uh, Here I have just started the formats for printing. This is for the real number, and the X is for the spacing. Introduce the spacing. So that's going to be the discussion of our next lecture.